This module examines break-even analysis. Break-even analysis is a common financial tool used to determine the level of revenues required to cover all of the relevant fixed and variable costs, and to set the amount of fees or user charges to recover the full cost of a service. Break-even analysis uses the concepts of volume, cost, and pricing to provide useful information. Volume is the number of units of service, such as shots given. Cost refers to the total of both fixed and variable costs. Another module will go into more detail on fixed and variable costs. Pricing is the use of volume and cost to determine a price for the service. That per unit price could be charged to a client or used as justification for central government funding or for donor funding. In using the cost-volume relationship, you'll be able to determine the break-even point, which is the level of activity that generates total revenues equal to total expenses, break-even units, which are the number of units that must be produced and sold to generate enough revenues to cover all costs during the period, and finally, break-even revenues, which are the level of revenue to cover costs during the period. A basic application of the cost-volume relationship demonstrates that if 1,000 units are sold at $4 each, there are total costs of $4,000. Then, break-even units will equal 1,000, break-even revenues will equal 4,000 in revenues, and the break-even point is equal to 4,000 in costs. The volume cost price relationship lends itself to a little more complicated set of equations. Let's explore them. Each of the letters in the equation stand for certain variables. Y means profit target, the amount you want to earn above costs. TR stands for the total revenues. TC stands for the total costs. Small letter p means the price charged. Small letter q stands for the expected or required sales quantity. Small letter v refers to variable costs. And FC stands for fixed costs. Now we use those abbreviations for these 5 equations, starting with one relationship to discover another one. Thus, it's really a step-by-step way to use one equation to solve for another. Equation 1 says that profit equals total revenue minus total costs. Equation 2 shows how to compute total revenue, which equals price multiplied by quantity. Equation 3 shows how to determine total costs, which are equal to the fixed costs plus the product of variable costs multiplied by the quantity. Equation 4 simply restates equation 1 by inserting the variables from equations 2 and 3. In other words, profit equals price times the quantity, which we found in equation 2, minus the result of equation 3, which computed the total costs. Total cost was the fixed cost plus the product of variable costs multiplied by the quantity. Equation 5 just simplifies equation 4. It says that profit equals price times the quantity, minus fixed costs, and minus the product of variable costs times quantity. We have a few more equations to define before we use them in an example. Note that a break-even point implies that profit equals 0, or where revenues just cover all of our costs. Restated in abbreviated form, it's y equals 0. Equation 6 inserts 0 as P, or profit, in the prior equation 5. It reads as the break-even of 0 profit is equal to the product of price multiplied by quantity, then minus any fixed costs, then minus the product of variable costs times quantity. Equation 7 is just moving the prior equation around using algebra to solve for fixed costs. Therefore, this equation now shows that fixed costs are equal to the product of price times the quantity, then minus the product of variable costs times the quantity. Equation 8 moves the prior equation around to say that fixed costs are equal to quantity times the result of price minus variable costs. Equation 9 goes the next step to solve for quantity, which is fixed costs divided by the result of price minus variable costs. Wow, that was a lot of algebra. So now we can catch our breath. But at least we now have various equation relationships to use in doing break-even analysis. We can now use those volume cost price relationships to determine the break-even point. First, we have to define or provide a number for variable costs, for fixed costs, and for the price to charge. Plus, we can even add in a profit target as part of fixed costs. Then we plug those numbers into the formulas to do break-even analysis. Here's the example. Assume you are the head or principal of a local school. You want to teach the children about community involvement by having a bake sale to raise money for HIV testing. The children will bake small berry pies in the kitchen of a local restaurant. You want to know how many pies the school will have to sell in order to break even. Each pie will be sold for $4.50. Plus, the school's goal is to earn $400, which is the profit target, for HIV testing. Here are the estimates for the various cost items for conducting and marketing the bake sale. Kitchen rental is $300. Kitchen cleanup costs are $150. Advertising costs are $75. Pie ingredients per pie is $1.10. Disposable aluminum pie tins are 20 cents per pie. Disposable utensils, including 2 forks and 1 knife, are 15 cents per pie. Now we can use those assumptions in a series of formulas that we derived earlier. So using these assumptions, we find that total fixed costs are the $300 kitchen rental, the $150 kitchen cleanup costs, and the $75 advertising costs for a total of $525. We then add the required profit target of $400, which makes a total of $925 in total fixed costs. Variable costs per pie are $1.10 for the ingredients, 20 cents for the pie tin, 15 cents for the utensils, totaling $1.45 per pie. The price to be charged per pie, we've already said, is $4.50. Now let's get into our equations. We solve for quantity as equal to fixed costs, which are the 525 plus our required profit of 400, for a total of 925. That's divided by 3.05, which is the result of the price of $4.50 per pie minus the variable cost of $1.45 per pie. Since we can't make a fractional pie, our result is rounded up to 304 pies. We then determine total revenue as the price of $4.50 per pie times our quantity of 304 pies. That produces total revenue of 1,368. To compute total costs, we have to back out the profit target as part of the fixed costs, so it simply goes back to just 525. After this change, we have total costs, or TC, equal to fixed costs of 525, plus the product of variable costs of $1.45 times our quantity of 304 pies. That calculation results in total costs of 965.80. Y, or profit, is then the total revenue of 1,368 minus the total costs of 965.8, which produces a profit of 402, which is extremely close to our target profit of 400. The difference is due to having to round up our quantity to the nearest whole pie. A common graphing method is to plot alternative quantities used in the formulas. essentially baking different quantities of pies. Our fixed costs of 925 stay the same regardless of the quantity level, so the solid black line is plotted across the graph. Total revenue, or TR in the prior formulas, increases as the set price is multiplied by different quantity levels. Those results are shown on the graph as the green line. Variable costs, which are a set amount per pie, in this case $1.45, are multiplied by different quantity levels and plotted on the graph as the orange line. Finally, total costs are a function of fixed costs, here including the profit target, plus the product of variable costs times different quantity levels, and then plotted on the graph as the red line. The red and green line crosses at 304, or the break-even point that will also make for us our required profit target of 400. Now let's change a few items in the prior example. Now we want to solve for variable costs, or small v. Assume you're planning another pie sale, but this time featuring a different pot pie that you will sell for $8 each. You expect to sell 250 pies at that price. Your fixed costs of 525 will remain the same, as will the profit target of 400. So the total fixed cost still equals 925. How much can you spend on variable costs? Just to be clear, you could use the formulas to solve for fixed costs if you didn't know that amount, but knew all the other amounts including variable costs. In this example, we know fixed costs, but not variable costs, or small v. Plugging these values into our formulas, we get the following. Quantity of 250 equals the 925 of fixed costs, which includes our profit target, divided by the result of the price of $8 minus our unknown variable cost. Rearranging the formula allows us to get closer to solving for variable cost. Using algebra, we multiply both sides of the equation by the right side denominator 8 minus small v. It cancels out on the right side of the equation, but leaves the left side with 250 multiplied by 8 minus small v. Then we move the quantity 250 to the right side of the equation by dividing both sides of the equation by 250. The 250s cancel out on the left side, yielding the equation of 8 minus small v is equal to 3.70, the result of dividing 925 by 250. Now we solve for small v, or variable costs, which is equal to that 3.70 divided by the $8 price, resulting in the calculated amount of $4.30 of variable costs that we can incur per pie. Given that we now know the variable cost, that solution allows us to derive additional information, including total revenue, total costs, and proof that our profit target is reached. Total revenue is equal to the price of $8 times the quantity of 250, which produces $2,000 in total revenue. Total costs are equal to fixed costs, excluding the profit target, of $525, plus the product of the $4.30 in variable costs times the quantity of 250. That generates total costs of $1,600. Profit, or Y, is then the total revenue of $2,000 minus total costs of $1,600. Our profit target of $400 is confirmed. If we knew everything about the price, we could derive a price which would cover all costs and profit. Price is equal to the product of our fixed costs of 925 divided by our quantity of 250, which results in 3.70. We then take that 3.70 and add the variable costs of 4.30. The result is that a price of $8 is necessary to cover all costs and our required profit. Price is simply the average cost of production. We can solve for quantity if we know the other factors. Quantity is equal to the 925 in fixed costs, that here includes profit, divided by the result of an $8 price minus the $4.30 of variable costs, or $3.70. When you divide the 925 by $3.70, you get 250, which is the quantity. This confirms the amount stated in problem B. In summary, there's very valuable information that can be gained by looking at the volume, cost, and pricing relationship. These formulas give the impression of preciseness. However, it's not all based upon estimating the service demand and agreeing on a price per unit. If you estimate service demand or sales too high, it may lead to funding more labor and materials than you needed. This will result in wasted resources that could have been better deployed. But if you estimate service demand too low, you may not have enough labor and materials to cover the demand as it occurs. Now, if you set the price per unit too high, it may drive away needy clients who can't and will not pay that price. But if you set the price per unit too low, it may not cover all of your costs. All of these decisions require careful attention to the cost, volume, and price relationship.